Hello, I see Colin just joined.
Hello.
Hello. Does everybody see me?
Yes.
Okay, cool. Don't worry, you don't need to share your camera. I'm gonna work on the slides most of the time. So, so let's give a few more minutes to other people to join. I see Vipra. I see Colin. Let's see if I see other people. I cannot hear you. I hear some noise, but let's see if it works.
Hello.
Yes, I can see you. Hi.
Hi, how are you?
Good. So you are Shipley, right?
Shilpi.
Shilpi.
Yep.
And I see also Vipra. Yes. And I don't see Rohit, but I see that he joined.
Yeah, hello.
Hello.
Yeah,
And
Professor, you can
Colin.
hear me?
Yes, I can hear you. Can you hear me?
Yeah, I can hear you, Professor. Yeah,
Awesome.
but my
So
video is
let's
not on because I am like on my way to home.
say that again.
I'm saying my video is not on because I'm on way to home.
Okay.
Yeah.
I see also Navia.
Yes, Navya here.
Oh, nice. I see majority, a female majority, which is a good thing. Okay, let's see. So we have, how many people we have here? Let's see if we can start. Let's give, oh, I think we waited enough, 7 minutes. It's okay. Okay, and by the way, I'm recording this thing, this session, and so we will have the chance to view it afterward. So and you can do me a favor, mute your mic. It will be really helpful. Okay.
Okay.
Cool. So welcome everybody to the course. It is, I must say that this is my first time that I'm doing an online course. So bear with me, and if you see things that you think that are good, the area of improvement, so please let me know. Please provide feedback as soon as possible, and I will try to accommodate some of your requests if it will make sense. So I am, as I said, I am going to be your instructor for this course. I still don't know how many live sessions we're going to have. The reason that I wanted to conduct the first session as a live session, just that I will have the opportunity to meet you in some sort of a person, so you will be able to connect face to the names and all these things. And then the other goal for a live session is to answer on specific questions that you have during your assignment or during your learning process at home, and maybe we can do some demos and stuff like that for the things that we are going for, the material that we're going to cover. In general, I think that for the regular material, that we're going to cover based through the textbook and the rest of the material, I don't think we will need a live session. So it's going to be something like on the mind kind of thing. Like if you will, if I will see feedback from you that says, hey, I read this chapter or I tried to do something and it didn't make so much sense, can you spend some time in the next live session and talk about it and then have some sort of discussion? I'm more than happy to do it. This is going to be more helpful for me to focus our live session, because I know that live sessions is a little bit difficult for you because you choose the online method because you didn't want to go to direct sessions, such as what we do here. So this is about the live sessions, and if you don't have specific questions right now, we can start. And by the way, if you do have a question while I'm discussing, you want to take note, please use the chat window to send these questions, and then I will try to find sometimes through the slides to answer it. And if not, I'm going to simply answer all the questions at the end of the session. Does it make sense? Good. For those who are muted, which is perfectly fine, you just need to nod with your head, and as I see it, so it's okay. Cool. I see here a question. Prasad saying, Professor, I'm not able to hear you. Prasad, where are you here?
I'm able to hear you, yeah.
Okay, and I see Barry just joined. That's good. The plugin threw me for loop as I try to enter video session, may be late. Okay, so I guess that we can start. Okay, so let me see, how can I share my screen?
Okay.
Do you see the slide? Can you please let me know if you see the slide?
Yes.
Awesome. Okay, so let's get started. The course name is Network Structures and Cloud Computing. This is a mouthful a name. It's basically a practical foundation. What the goal of the course will be is to have a practical, to get a practical foundation in cloud computing and hands-on experience with cloud tools. Okay. There is several textbooks for this course. The first textbook will be the Data Center as Computer. This handles the theoretical aspects of cloud computing from the way that a cloud service provider builds. So it talks about how you do it, how you build a computer. It's the best analogy for this thing will be how you build a computer. So you have the motherboard, you have the CDs, you have all the I/O devices and all these things. How you make all of this working together. So the textbook is actually talk about these aspects in this sense. I like this textbook because it helped me a lot to understand few anecdotes and understand really what is important when building a cloud system. The reason that I chose this textbook is to give you the idea of how things are happening for the companies that are enabling cloud, such as Google, Microsoft, and Amazon. It will be helpful for you to understand the material that we are going to cover, because it's going to make more sense when you're going to address design aspects of the application that you as a tenant wants to deploy, you as a company wants to run on the cloud. The cloud tools that we are going to use, the cloud environment that we are going to use is mainly GCE, Google Cloud Computing. The reason for that is simply the cheapest platform. So Azure or AWS does a very similar thing, similar things for the sake of this session. So we're going to use GCE. So for that reason, I ask you in the first homework to go through and create a subscription for GCE, and I think, and please correct me if I'm wrong, you get, if you follow the link that I sent, you will get 60 days for free, and then I hope that I will be able to get some credits that I can share with you to even after these 60 days are passed, or you finish the budget that you have, you will be able to use this credit and hopefully don't pay much for the compute resources. As far as grading is concerned, 50% of the grade will be for based on quizzes that we are going to conduct between 3 and 4 weeks. We're going to have an essay every week that's going to take 10% of the whole grade. And then by the end of the course, you will have a project that you will need to deliver. The project will include a project, a report. It's some sort of a paper that describes the problem and the solution that you applied, and then 15% of the grade will be for the presentation of this project. Okay, so so as I said, if you feel something is wrong and you want to get some feedback, and you think that I should change the course or change something, or you want to learn a little bit something more and you want me to put some more emphasis in another area, please let me know and I will definitely look into it. Okay, so let's jump into the definition. So as far as definition is concerned, cloud computing is defined by the NIST. This is the federal the administration that handles cloud computing. It's a model for enabling convenient on-demand network access to shared pool of configurable computing resources. And I think that it makes sense in terms of if you first understand what are the resources. The resources are, you need to have the computer, right? That can do something, that can do some calculation, that can, like every computer, and then it needs to have a storage, a persistent storage, and then you need to be able to connect to it, which is the networking. So these are the three things, essential things that define the resources. Now, on top of that, you can have applications and services. Services will be some sort of aggregation of the first three. Okay, so for example, if I want to offer you a special storage service, I will, as a cloud provider, will go and build some solution, will apply some software into this solution, and then offer the storage solution as a service for you. Okay, so this is why I called out that the resources are the sets of network compute storage application and service. Okay, and basically the key here is that resources rapidly provisioned and released with minimal management effort or service provider interaction, and this is a key thing for cloud computing. What we want to achieve by moving into the cloud is to provide agility and innovation to the organization workload. So if, for example, you have a really great idea and you want to share it, or you want to actually make a business of it, the time that it takes you to deliver this feature into the cloud is critical. To deliver this feature to your user is critical, and therefore the speed, the time that it will take you to go GA, what we used to call it, what we call it, global availability for your users, it's critical, and this is what we are going to, one of the things that we are going to discuss during this course. And now in the next slide is we're going to discuss the value proposition and challenges. Okay, basically, cloud computing offers the premise of massive cost saving combined with increased IT agility. And what I mean by that is that if you think about what we had before the public cloud exists, if you had an idea and you wanted to offer it and you want to run this idea as a service or as an application, you would have to go and buy the servers, buy the air condition, running the servers, managing it, and maintaining it, and do lots of things that are not the core business of you as an organization. So think about it as, for example, Netflix, right? So Netflix runs now on, most of its workload runs on AWS. And the reason for that is that their core business is content and video and delivering video streaming to their users. So they don't want to be in the business of the air conditioning and building the data centers and securing it and all these things. They prefer to buy it as a service from the service provider, from the cloud service provider, which is Amazon. And by doing it, it allows them to stay focused in their core business. Okay. By the way, this is not necessarily means that it's cheaper. Sometimes it's even more expensive. And if you look at companies such as Dropbox, for example, said that their scale does not make sense for them to work on public cloud because it just costs more money. So they prefer to build their own solution, what we call it private cloud. Okay. So yeah, it challenges many traditional approaches to data center and enterprise application design and management, and we will see how it is impacting it. And one of the biggest challenges is security, interoperability, and profitability. So let me make a quick pause here and see if you guys have questions. No? Okay, so I assume that if you don't post the questions, I'm just gonna continue to go through the slides. Okay, and now we're going to talk about the essential characteristics of cloud computing. It's basically on-demand self-service. Okay, so you don't, like as you did in the first assignment. You simply, without me even teaching you anything, you could create a user, you can provision a VM, and yeah, so you are essentially ready to go and do your stuff and do your business in the cloud. So self-service is a key, and on-demand is another important key where you don't need to think in advance of how many capacity would you need, how many machines do you need. Because in the old model, you will have to think about it before, 6 months before, and then make the ordering, the hardware ordering, and until everything is shipped, then you will have to start working on deploying and the build up and all these aspects. So on-demand self-service is, I think, one of the key characteristics of cloud computing. It allows rapid elasticity, which is correlated with the first part. and I think it's not measured service. Let me just correct it. Is managed service. Okay, it's managed service. Managed service means that, again, you don't want to, as a company that runs application for organization, some, I don't know, some CRP or something, you don't want to pay and to go into the details of the security team, the guards that are guarding your data centers. Three service model. Now there are the three service model are not that important, but since there are quite frequent buzzwords, so I wanted to call them out. In my opinion, those service models will converge in the future. Okay, so the first one is SaaS. Okay, SaaS is a software as a service. You have a software and you just want to provide it to your user without any knowledge, any technical knowledge of the product itself. So, for example, if you have a system that knows how to, let's say, run. I think, trying to think about an example. They try to run a expense report, okay, for organizations. You will just get username and password, and you will log in, and you will do all the stuff. You will not care about anything about the service. It's just you're gonna get it as a service. The software. Now, the second classification is PaaS, which is the platform as a service. So if, for example, you want to control the behavior of the application and you want to apply the business logic without caring so much about how to scale and how to handle specific platform aspect, then PaaS will be a good choice for you. And the last one is IaaS, which stands for infrastructure as a service. And infrastructure as a service means that you got the VM. You just simply got the VM without doing anything.
But I cannot see the presentation.
Is everybody going to see the presentation?
No, even I cannot see the presentation.
Professor, I think the screen is not shared, if I'm not wrong.
Yes, even I think the same.
Okay. Oh, you know what? I think. Okay. Okay. Let's see. I think I know what I'm doing wrong here. Can you see now?
Yes,
Yes.
thank you.
Okay. So this is the three items that I mentioned. I will try to avoid full screen. I think that will be more helpful for you, so it's not gonna. Okay. So yeah, so these are the things that I just discussed, and this is a figure that I like to use to explain an analogy to explain the difference between the various offering. So if we look at the analogy is that you have a car, right? And if you are owning the car, you owns everything. You need to come up with money. You need to take care of the depreciation, the servicing, the insurance, the road tax, the garage, the fuel, the road tools, and the driver. Now, when you use IaaS, you don't need to take care of where to buy the car because somebody get it for you. You pay for it, by the way. You lease the car from some company that provides you this, and you pay a monthly fee for it, okay? And then it's basically the financing, and sometimes it provides you the financing options, and the monthly fee encapsulate also the depreciation fees. Now, if you want to do, hire a driver and you don't want to drive, sorry, if you want to drive but you want to use even more coverage of the service, which we call car hire here, is that basically you add the servicing. You don't want to handle all the servicing, oil changes, and road tax and garage, and all these things are getting as part of the service. And taxi is the SaaS, is like you basically care about going from point A to point B without caring about where every piece is handled, which is the analogy for taxi. I don't know if it makes sense. I found it useful, and if it's not, that's fine. So if we go back to the essential characteristics classification, there are 4 deployment models. The first one is the private cloud. So as I said, companies that are big enough, such as Facebook, Salesforce, Dropbox, they prefer to run their private clouds and not use the public clouds from various reasons. One of the reasons is their core business and sometimes big conflict of interest, where Facebook does not want to run on Google because they're competing on their advertising business. There is a community cloud, which is OpenStack. Essentially, OpenStack is a standard that suggests to organizations how to build private clouds. So it's kind of a community thing. And then there is the public cloud, which, as you know it from Azure, GC, and AWS. And lastly, there is hybrid cloud, where organization says, okay, you know what? I have a couple of workloads that I want to run on my premise, on my private cloud. However, I do have other workloads that I want to process in their public cloud, okay? And I want them all to be connected, and this is hybrid cloud. This is we are really in early stages in the hybrid cloud world, but basically private cloud and public cloud is the 2 deployment models that are the predominant in the market today. Yeah, so cloud computing workloads. So essentially, when we are as a customer now, when we are about to process something, this is what we call workloads. Okay, so essentially it is answering what is running on the cloud. So there are two I see. Yeah, there are mainly 2 classification of workloads. The first one is online. The second one is offline. And when I'm saying offline, it means that it's not really connected. Maybe the classification here is not describe accurately what I'm trying to convey, but essentially online is you have a user. For online method, you have a user and it's doing something and it is expecting to get a response immediately. So I would change it to synchronous, and the offline is asynchronous. And what I mean by saying asynchronous is that you have a bunch of files that needs to be processed, that needs to be copied from one place to another. It's something that requires compute resources, but there is no user that are actually waiting. When you're doing email, for example, you want to get your new email immediately. When you do photo, you want to, when I send or messaging, you want to see this thing happening immediately. So these are the 2 classification, and also the server-side computing is easy to manage. And one of the important aspects of cloud computing world was that there is no need to update many millions of clients. Okay, so for example, a new Windows disk. Okay. And again, I am reminding everybody, if you do have a question, please post it, okay? See here, Professor, how would the quiz can be conducted? Professor, project will be in group or individual. Okay, I'm going to talk about it later, okay? But I want to finish this aspect first, through these slides as well. So how does it running, okay? So, and you're going to read it through the first chapter of the textbook. Warehouse scale computers are essentially include many data centers, and in every data centers you have many clusters, and in every clusters you have many racks, and racks hold servers, and servers hold many CPUs and storage, right? And basically it is, since they are all running in high density, there is some sort of, we achieve some sort of a cost efficiency. And this is one of the way to look at that, okay, is a 1U server on the left and 7 rack with an Ethernet switch in the middle here, and the diagram of a small cluster with a cluster level Ethernet switch routed to the right. Okay, basically you don't need to remember all these details, but essentially is a way to take lots of compute resources and put them together in some sort of density and operate them, okay, effectively. Now, having said that, cloud computing is not just a collection of servers, okay? It's not what I specified here. This is specifying the data center basic elements, but it's not enough. So you have several data centers that are all connected, but what does it do? How does it fulfill the very first thing that I called out here as the value proposition? Okay. How it's provide the interoperability, the security, and the profitability for the organization. So again, cloud computing is not just a collection of servers. There is a software that runs and manages these things. So the software and hardware run at scale across many servers, racks, and data center, and as a single computing unit. So there is some kind of a secret sauce that aggregate all these things and consider it as one resource, big resource that can be used to process those workloads. The large scale requires special design for fault behavior, and we're going to talk about it. This is a very important piece. Efficient power and energy consumption, continuous deployment, and continuous integration. Continuous deployment and continuous integration refers to the process of the service provider, that actually the company that has the service that users are getting, are connecting to and doing the business with it. And from the moment that the new code is available for its users until it's pushed to the production and it's make it available, this is the process that we call continuous deployment. So there is always processes, there is always the developers of that service are always working and releasing new features, and there is a process that always push the new features to the production. Now, you're probably going to ask me, but it sounds like not so clever, because you need to test the new code, you need to check it in various ways, like I don't know, check that it's from functionality perspective it's working, and also checking that it's not crashing from any memory leak and all these things. So continuous deployment is one of the services that cloud computing can offer an organization to use when they are developing, when they are offering their cloud, their platform as a service. Very important to understand those four aspects: continuous deployment, continuous integration, fault behavior, and efficient and power consumption. If we look a little bit on the power usage of data center, this is a little bit outdated. There are things that, since it's in percentage, it's still accurate. But the more you get, the more that those cloud providers are growing, they are also improving their power usage. But I guess that the point that this figure wants to make here is that if you look at that, CPU take 33% and DRAM, which is the RAM, the random access memory, and the networking is consuming most of the power, but 22% goes for other things. Okay, so there are something like 78% utility of the power. Okay, this is what you need. You wanted, remember, you wanted to have a network, resources, aggregation. So you want to have disk, storage, you want to have CPU, you have to have network, and the RAM that you use for the CPU, which is another type of storage. And you lose 22%. And just to see if we are on the same page here, do you have an idea what will be a major component of this 22%? You can post your answer, or you can just say it. No one? Lights. Good. Yes. What else? Come on. What else? You are getting closer, Colin. Okay. Let me ask you another question. HDD LEDs. Yeah. That's good. I understand the light thing, but I was referring to something else. So let's think together. When you have a computer at home, fans, cooling, yes, so definitely. So I think that the vast majority of the power user loss is for cooling. Okay, cooling is a big part of it. Okay, so when you see somebody that if you hear about a company that wants to go into the cloud business, 20% of their stuff that they're going to do will be in the air conditioned business. So there is a lot of research and activity today that actually handle how to handle optimization of data center cooling. Okay, and now and this is basically the part that I wanted to cover. All these things are well documented in the textbook. So what I want you to do is basically get access to these textbooks and start reading it. And hopefully the quizzes will check your reading. And now I'm going to address the questions about quizzes and the project. So let's talk about the course project. Okay, so the course project, one of the things that I like to do here with in this course is not going through the regular rhythm of course, quizzes, assignment, and grading. What I want to do here, I want to do a little bit something a little bit different, because in this course you have an opportunity to design, develop, and deploy real product on the public cloud. That, by the way, you can use as a topic for your work interview. So this is, I think, a great opportunity, and this is why allocated something like 35% of the total grade to the project. So don't see it as a big burden. And I also, I think that it's gonna make you a little, it's gonna make it a little bit more complicated. But what I'm going to do here is that I'm not going to tell you so much thing about what to do in the project, okay? I will ask you to think about it, okay? So essentially, you have the opportunity to build and deploy anything, okay, that you wanted, okay, and that makes sense to you as well, okay? What I want you to do is, and this is very important, I don't want you to just go through something and just build it without any framework. Following through some framework is super important, regardless to this course, okay? It is important to any process that you, any engineering process that you're gonna do in your career. So therefore I am offering you this school framework that I like very much. It is listed here in the slide. By the way, I'm going to share with you the slides after every session. It's basically going through the 4 steps of empathizing with some problem, defining the solution, ideating the solution, prototyping, and testing it, okay? So you can think about any problem that you are interested in, and deploy and go through this framework and deploy it to the cloud. I know that it sounds vague, but it is vague on purpose, okay? So I guess what I'm trying to say is think on some problem you wish to solve. And again, there is no right or wrong. If you want, you can work in groups and start today, okay? Because don't think that, okay, I will have to deliver this project in 3 months or in 2.5 months, so I have some time. No, you don't have some time. The reason that I want to ask you to do it now is that you need to go through the process of thinking and fixing it, okay? And if you will do the course project in the last week, I will be able to see it, and trust me, it will not be good. It will not be good, not for you and not for the whole overall goal of the class, okay? By the way, do you have any questions about, oh, I see, what kind of project we can build and deploy? So if you know how to code and you are comfortable with JavaScript and stuff like that, you can go and build something from the beginning and yeah, think about something, okay? And the thing can be any scenario. So for example, you want to build some service, and this service requires some sign-in scenario. So I want you to build this thing, meaning that your application will allow people to, I don't know, chat service or messaging service or photo sharing or even a store that you want to sell specific things to customers. Okay, so anything that in this range of spectrum, you can go if you know how to write it with your software skill. That's fine. Sometimes you don't have those skills, and that's fine as well. You can go and look for research for pre-made packages that one can use. In the last course, for example, I saw a team of students that took a package of software, okay, a package of software, and they just populated with all kinds of material, of the things that they want to sell, and this was essentially a store, an e-commerce system, and they deployed it into the cloud in a way that it was highly available, and if one node went down, they took care of it, and these things. So for this particular project, they didn't have to write even a single code of software, but single line of code of software, I mean. But essentially, this is the idea. Will you form a team, or we? No, you can decide. I'm not going to be I'm not going to be in the business of you know, telling you, because I don't know you. So I trust that you have the ability to partner, and this is one of the things that you will have to do in your work as well. Any other question? Okay. So summary, cloud computing is a smart shared pool computing method. It requires a special architecture design. It introduces new carbon generated source, requires to be environment friendly. The reading for week 2 is chapter 1, intro, chapter 2, workloads and software infrastructure. We're going to discuss this aspect in maybe in the next session, in the next live session, and if not, I am going to share with you the presentation, or maybe share with you the video that I am describing this thing. So I'm not sure that we are going to have a live session. Again, it really depends on you. If you think that it will help you, I'm more than happy to do it. And the first quiz is planned for week 4. Now, I think somebody asked about what will be the quiz look like. It's basically questions about what we discussed, okay? So if you read the textbook, if you listen to the lecture, if you did your homework, you should be good. Any questions? Okay, and this is how we are going to conduct. Is there any need for proctor? I don't know yet. I don't know yet. I don't think so, guys. Again, I you know what? I can say no. I can say no. We don't need a proctor. I mean, it really depends on you. Again, see this course as an opportunity for you to collaborate with people and with me, and try to learn as much as you can. I mean, I know that grade is important, but there are other important things. So it was a very long answer to the question if there is a need for proctor. So I'm gonna trust you here, and I hope that you will use this trust wisely. Okay. Okay, let's see if how can I do it. Stop. Okay, so yeah. So I guess that I covered most of the things that I wanted to cover. Any question before we are adjourning? Nothing? Cool. Okay. So thank you for joining. And I guess we should see each other in the next 2 weeks or 3 weeks or whatever. but I'm going to be in touch. So the way that we are going to do, we're going to use the Hangout chat to post all kinds of really immediate questions. If you want, you can send me an email. And also, I'm going to post all kinds of announcement and homework through Blackboard. Does that make sense?
Yeah.
Yep.
Okay. How many you are? 1, 2, 3, 4, 5, 6, 7. I guess the 2 makes sense, but again, if you're gonna come, so the question was how many members in a team? I think the 2 is enough. But again, if you have a really big idea and you think that you have each member has a specific skill set to fulfill this project, and you will be comfortable with 3 more than 2, please shoot me an email with all this justification, and I'm just going to look at that. I in general, I don't have a problem. I just think that 3 creates more complexity, and 2 is enough. And by the way, you can go by yourself 1. You don't have to do it in groups. But just be ready and with an idea of what you want to do. Okay, and this is not just something that you write. You need to investigate and analyze and go through it and look in the internet and look at other sources, what the worlds need and how you can help. And just don't limit yourself. Just think about any idea and just try it. Okay?
Okay.
Cool. So thank you very much, and talk to you later.
Thank you, Professor.
Thank you. Bye.
Bye-bye.
Thank you, Professor.
Bye.
See you, Professor.